Hi, welcome to our new unit. We're going to be starting Unit 6, which is right triangles and trig. But before we even go into that, we're going to do a little review of radical properties. You have already encountered this in algebra. You may remember it. You may forget it. We're going to go over it anyway, so that way it's in your mind, because we're going to be dealing with radicals, especially when we're doing trig and dealing with right triangles. So if you know the basics for that, then when you encounter it, there shouldn't be no issues for doing it. So lesson 6.0 is review of radical properties, and the objective is simplifying and applying operations with radical expressions. So when it comes to square roots, we have the product property of square roots. The product property of square roots is basically the product of the square root that can be written as a product of the square root of each factor. So basically, if you had something that's a times b underneath the radical, it can be split up into 2, and it would be written as square root of a times square root of b. So the example shown below, we have square root of 20. It can be broken into factors 4 and 5, and it'll be square root of 4 times square root of 5. And you know, square root of 4 can give you it will give you a perfect square of 2. So that'll come out from underneath the radical, and square root of 5 just stays as is because it is not going to give us a perfect square, and plus it's a prime number. So the square root of 5 is the same as square root of 20. If you're not convinced, you can put into your calculator and see that both of them will give you the same value. All right, so the number underneath the radical sign is called the radicand. This is just a little fact in case you come across it. They mention the word radicand. You'll know, oh, okay, that's the number underneath the radical sign. To simplify radicals, the first step you need to do is you need to factor out the perfect square. So when we did the example of square root of 20, we're looking, at least one of the factors have to give us a perfect square. 4 was that number, because square root of 4 gives you 2. Once you do that, take the square root of the perfect square factor, then represent the simplified radical expression as a product of a whole number. So that's the number that was simplified and comes out, and then the non-perfect square radical, which will be underneath the radical symbol. Please note that radicals, unless they are perfect squares, are irrational numbers. If you have, for example, 2 square root of 5 is irrational. But if you have the square root of 4, it's going to give you a whole number of 2. Then square root of 4 is rational. So the non-perfect square are exact answers written in simplified radical forms, not decimal. So if you see 2 radical 5, that is the simplest radical form. But you're not going to try to find the square root of 5, plug it into your calculator, and get me a decimal. That's not what I'm looking for. It has to be simplified radical form. All right, so we're going to do examples based on simplifying radicals. So for the first one, we have square root, and try that again. All right, so we have the square root of 72. So we need to find 2 factors that will give us the square root of 72. Okay, so again, one of them has to give us a perfect square. So if I were to go down and find all the factors of 72, so I'm just going to do this for this once. We have 172, and then 72 divided by 2, we have 36 and 2. We also have 9 and 8. There's many factors for 72, but I'm going to go with the highest number that gives me a perfect square. So then I'm going to break it down to 36 times 2 times square root of 2. Go further down, square root of 36 is 6, so that comes out, and then since 2 is a prime number and I can't break it down any further except to itself and 1, it will stay underneath the radical because it's prime. You could use any other factors, but I'm trying to find the highest number that give me a perfect square, so that way there'll be less steps. Because if I did it with 9 and 8, I can further break down 9 and 8, and there'll be more factors and get to the in order for me to get to the simplest form. I'm trying to find a shortcut or an easier way to get from this to the simplest radical form. All right, let's do 3 and 4. When you have a number in front of the radical sign, Just bring it down until you simplify whatever's underneath the radical, and then combine and then get your final answer. So I'm just going to rewrite this, and then I'm going to simplify what's underneath the radical. This is 3 times radical 75. 75 can be broken down into 25. 25 will give you a perfect square, and then you have 3. So 3 times, this would be 5 times square root of 3, and then when you simplify 3 and 5, you get 15, and it's radical 3. And there you go. Same thing with number 4. I'm going to just rewrite this, and then 6 times, I'm going to get 2 factors that give me 27. That's square root of 9, square root of 3. So basically 9 will give me 3. Square root of 9 gives me 3, and then 3 will stay underneath. It's a prime number. And then I can go further down, simplify, and then I get 18 square root of 3. If you were to plug this into your calculator, 6 square root of 27, and then 18 square root of 3, you will see that both of them will give you the same value. So that means that you did the right steps, you factored correctly, and end up with the exact answer. Okay, next one. We're dealing with exponents. So what happens to an exponent when we square it? So when you're squaring it, basically you're multiplying. So that's what you're doing. You're multiplying it. And what type of number is the exponent if it is a perfect square? It has to be an even number. This is with exponents, because when you have to when you have an exponent and it has an even number, you could put it, I should say split it, divide it into 2, and it will give you a perfect square, because one of those, like let's say x squared and then another x squared, it give you x to the 4th power. That's a perfect square. So anything even, any even exponent will give you a perfect square. However, sometimes you're not going to have an even number, and it will be an odd number. So when you have that situation, split it into an even power, a highest even power, and then the power of 1. So it says if a variable is raised to an odd power, then it needs to be broken down into a product of an even power and the power of 1, first power. So anytime you see that. So we're going to do examples based on that underneath the radical. So for this one, we have x squared of 13. So basically you can rewrite it as x to the 12th power times x to the 1st power. And then if you want to make it easier for yourself to separate it so you know what you're working with, that's fine. So when I see this as an odd, basically you just divide it by 2. So then that means it will be x to the 6th power, and then this will be x underneath. X to the 1st is the same as just x by itself because that invisible one is there. And then you have your answer. So this is equivalent to this. Let's do it for this one. This can be rewritten as, this would be a longer one, so it would be x to the 4th times x to the 1st times x to the 6th times x to the, that's a y. Let me make sure. Y to the 6th, y to the 1st. All right, we got 2 different variables, so pay attention to that. So right away, x to the 4th, you divide it by 2. It's an odd even number. It'll give you x to the square. And then you'll have y to the 6th. That divided by 2 will be y to the 3rd. What's left underneath is the x and the y. You just leave it as x times y underneath the radical. And then here you have your simplest radical form for this exponent. Now if you do it with numbers, do like that. You have 49 and then this one. So let's break it down underneath the radical. We have 49, then we have 5 to the 4th, and then 5 to the 1st. You know the square root of 49 will give you 7, so take that out. X to the 4th is an even power, so you can divide it by 2 and get x to the 2nd, and what's left over is x underneath the radical. And then you have it. Okay. Next one, a fraction in its simplest form is in its simplest form if there are no perfect factors, there are no perfect square factors are in the radicand, and no radicals are left in the denominator. So this is where if there is a square root in the denominator, we need to rationalize the denominator. Rationalizing the denominator is a method used to eliminate radicals from the denominator of a fraction by multiplying the entire fraction by the denominator's radical. Sounds like a mouthful, but we're going to do an example so that way you understand what is going on. So the first one, we have square root of 10 over divided by square root of 3. We need to get rid of that radical. So you remember like when we had like any fractions or any anything with I'm trying to think, powers, negative powers, anything that is odd in the denominator, we need to get rid of it by either doing like reciprocal or whatever the case may be. So this is almost like the same thing, but we're going to multiply it to itself, because when you multiply a radical that has the same number underneath it, it's going to cancel out the radical and give you the whole number. So this one, we're going to multiply 3 over radical 3 over radical 3, because we need to get rid of that in the denominator. So this will give us 10 times 3 is 30 underneath the radical. And then if you were to multiply it, this would give us square root of 9. But the square root of 9 is nothing more than 3. So now let's see if we can break down 30 to its simplest form. The two factors that I can think of, we have 6 and 5. If I go any further with that, we got 3 and 10. 6 can be broken down, but it'd be broken out to prime numbers. So this is the simplest form, because you don't want to have like three different radicals on the top. You will basically end up combining it. So 30 is in its simplest form. We can't find a number that we can give us a perfect square to break it down further. So that is our answer. Same thing when we do with when we have the whole fraction underneath the radical. Just break it down into two separate radicals with its term in it. You could do it like this, and then if you break it down further, we got 5 times c to the 4th times c to the 1st, and then we have the radical 4 times d to the 4th times d to the 1st. All right, so now c to the 4th will be divided by 2, and it'll be outside. 5 and c will stay inside because 5 is a prime number and c has an odd number, odd exponent, so it'll stay like that. And then d and 4. 4 perfect square of 2, d divided by 2 gives you d of 2, and then you just left a d. And there you go. That's your answer. This one's been split up for us, so we can just continue working. So 16 square root of 16 is 4, and n is an even number, so it would be just n. And at the bottom, 12 can be broken into, I'm going to put n outside because n to the 2nd power, because you're just dividing 4 into 2. And then 12 can be broken into 4 and 3. And if you continue any further, square root of 4 gives you 2, so then 2 will come out, and then you're just left with 3. Now you can simplify. 4 divided by 2 gives you 2. N, since there's one n, that can be canceled out, so let me use that with a yellow. And then since there's 2 n's at the bottom, you can cancel out at least one n, so remove that, and you will be left with 1 of the n. We already simplified this. So n will be at the bottom, that's what's left over, with square root of 3. And actually, you know what? I can go further with that because we cancel. This is left with 1. We're left with the n, and then this was 2. All right, actually, let me expand this page and scroll it down. And then for this one, when you see it like this, it's the same as if we have square root of 2 times square root of 7, and then this one is underneath would be square root of 7, and then square root of 3. The way that I wrote it is the same way as this. You basically just splitting up the fraction and having it square root for each of them. Now, before you even go any further, see what you can simplify or cancel out. There's a 7 on square root of 7 on top and bottom. You can cancel that out, and then what you're left with is going to be your answer, square root of 2 over square root of 3. And it's already a prime number. It's already simplified. That's it. Okay, next one. Radicals expression can be added or subtracted in the same way that a monomial are added or subtracted, basically by combining like terms. So you see, we dealt with monomials in algebra, and basically when you have the same term, when you have the same variables, you just add them. This would give you, let me make sure I'm using the right color. You would have this as 9x. So same thing with radical expression. If you have the same radical expression, this will be 9 square root of 11. It's just like this if this were a variable, but instead it's a radical number. So we're going to do the examples for the others. So all of these have square root of 3 in them, so we can combine them. So these two will give you 10 square root of 3, and then 5, you bring that down, and then you combine it further. So that would be 5, 10 minus 5, 5, and then square root of 3. This one, make sure you combine them the like terms. So it's square root of 12 square root of 5, and then negative 8 square root of 5. So we're going to combine that. That's going to give us 4 square root of 5. And then these two, I'm going to just put in 2 lines underneath. Those two you're going to combine. That'll be 9 square root of 7. That's it. You can't combine these two because they have different numbers underneath the radical, so you leave it as is. And then for the next one, I'm going to make this bigger and then spin down. Okay, so now this one you have to actually simplify this, and then we can start combining if we can. So 2 brings down 50. Find 2 numbers. Oh, that was weird. We got find 2 numbers that will 2 factors that will give us 50. We got 25 and 5. 25 and 2. And then for this one, bring down the 3 and find 2 numbers for 32. See a perfect square. We got 16, and then we got 2. Make my 16 look normal over here. And 2. All right, so now I know that I'm going to bring down 2. Square root of 25 will give me 5, so I'm going to multiply that to 2 outside. But what's left over is a 2, so it stays there. With 3, the square root of 16 is 4. So I'm going to multiply that to 3 outside, and what's left over underneath the radical is 2. All right, now I need to combine. So this will be 10 square root of 2, and then this will be 12 square root of 2. They both have the same number underneath the radical. I can combine that. So I'm going to be subtracting, and it'll give me negative 2 square root of 2 as my answer. And again, like I said, if you're not convinced, you're not sure that you have the right answer, put this into the calculator, see what the value is when you combine this, and then put this and see if it gives you the right answer. If it's the same value. If it is, then you did everything correctly. All right. Next. So now, when you multiply in radical expressions that contain a binomial, you've learned about binomials, basically 2 terms combined by addition or subtraction. You use the distributive property. So for the first one, whatever's outside, you're multiplying to the terms inside. So basically, it's 2 square root of 2 times square root of 8. Do that again. I don't know why is it doing that. Whatever. And then plus square root of 2 times 4 square root of 3. So now you're going to combine that. That's going to give you square root of 16 plus, and then For this one, since that's that invisible 1 there, you're going to multiply what's outside the radical, so that'll give you 4, and then what's inside. This is the only time that you can actually combine whatever different numbers underneath the radical is when you multiply. You can do that. So it'll be 6. So square root of 16 is going to give you 4. And then you could just bring that down, because 6, if you break it down, it'll be 6, 2, and 3. They're prime numbers. You can't really break it down further, so leave it as 6. So this would be your answer. You cannot combine that because they're not like terms. So leave it like this. Now when it comes to this, there's something that I taught you in algebra where you can use the box method for this. So you put 4, and then you got square root of 5, you got 3, and then square root of 5. Make sure you put whatever sign in the front of it, but since it's plus, that's fine. So this will give us 12. You're multiplying this, and this one you're going to multiply will give you 4 square root of 5. This will give you 3 square root of 5. That will give you square root of 25, and square root of 25 is 5. So now you can start combining. So then 12 and 7 will give you 17, and then 3 and 4, they both have the same term. They're square root of 5, so that will be 7 square root of 5. And that's your answer. Right. Okay, so we've reached the end of the review of radicals. So let me go back as a recap, if this goes any faster. So we learned the different types of ways of operations when dealing with radicals. So for the first one, we dealt with simplifying. So basically simplifying is finding the two factors. One of them has to give you a perfect square, and if you look for the greatest factor, that will give you, oh my god, I went back too far. It will give you the greatest factor that will give you a perfect square. Then you use that, and then the other number will be a prime number where it will stay underneath the radical. And don't use decimals. Simplest radical form means you have a number that will be underneath the radical. And then you also learned about exponents. If you have an even exponent underneath the radical, divide it by 2 to pull it out. If there's an odd number, split it into one of them. There will be an even number, and the other one will be a power of 1. And then you can simplify. When you have a radical in the denominator, you need to multiply that radical number top and bottom so you can get rid of that radical at the bottom. And then you simplify wherever is needed. And when it comes to multiplying, adding or subtracting, you're basically adding and subtracting like terms, just like you do with regular polynomials. So if they both have the same number underneath the radical, then you can combine those. But the numbers outside the radical, the number underneath has to stay the same. If it's different, you cannot combine them. And with multiplying with distributive property, the same thing as you do with a regular distributive property, distribute, and then if there's anywhere we need to combine it. If you're doing two binomials, multiplying it, use the box method, or you can use FOIL, the first, outer, inner, last, in order to simplify it. And again, if you cannot combine if it's not like terms. All right. So if there are any questions, again, this is review stuff that you did in algebra. If you need a refresher or you're confused about something, please do not hesitate to ask or email. All right, so this concludes our lesson, and have a good day.